Starting on page 2, we're going to discuss how we can use sum and difference formulas to find exact values. One use of these sum and difference formulas is to obtain the exact value of the cosine, sine, or tangent of an angle that can be expressed as the sum or difference of angles whose sine and cosine are known exactly. All right, well, what in the world does that mean? Well, let's take a look at example 3. Okay, there are several expressions that we're going to have to find the exact value of. So let's take a look at them. We first have in part A the cosine of 165 degrees. Then we have the cosine of 7 pi over 12. Then we have the sine of 17 pi over 12. And then there are more on the next page. We have the tangent of 15 degrees, and then we have the cotangent of negative 5 pi over 12. All right, so what's so bad about that? Well, let's take 165 degrees, for example. Okay, if I go to the unit circle and I look at the degree angles, I don't see 165 degrees. Okay, that doesn't mean it's not there. It actually is. Okay, 165 degrees, if you had to draw it in standard position, here would be your initial side, and then you would rotate counterclockwise, and you're going to end up just past 150 degrees. Okay, so 165 degrees is going to be somewhere about here. Okay, the problem is this angle is not called out on the unit circle. We don't know the XY pair. We don't know the coordinates here. Okay, so that's going to make it extremely difficult for us to come up with the 6 trigonometric functions of 165 degrees. Okay, the same is true of the other angles that we saw. Okay, 7 pi over 12, 17 pi over 12, and so on. 15 degrees was on the next page. Those angles are not emphasized on the unit circle. Okay, so it's going to be difficult to compute their trigonometric functions. So what can we do? Well, we can use the sum and difference identities. Okay, let's take a look at as to how we can do this. Okay, let's start with the cosine of 165 degrees. Okay, what we're going to do is concentrate on the angle here. We want to take two angles that are on the unit circle, and we want to either add them or subtract them to get 165 degrees. Okay, and more than one combination can work. Okay, the first thing that jumps out in my mind is 165 degrees is 135 degrees plus 30 degrees. Okay, those two angles, if you add them up, you will get 165 degrees. Another pair, okay, you could also do it as, I see, 120 degrees plus 45 degrees. That's another pair that works. Okay, so you want to find two angles on the unit circle that you either add up or subtract to get positive 165. Okay, so I don't know, just pick a pair. Okay, I'm going to go back and I'm going to use, I think I'm going to use 120 plus 45. Okay, but you could use the 135 plus 30. Okay, so here we go. Okay, I want to compute the cosine of 165 degrees. Okay, so I'm going to rewrite 165 degrees. Okay, this is going to be the same thing as the cosine of 120 degrees plus 45 degrees. Okay, it does not matter which order you put them in. Remember, when you add two quantities, the order does not matter. So we could have also put 45 minus 120. However, if you are subtracting, the order does matter. Okay, all right, so now what's happening? Okay, well, this is going to match up to something. Okay, if I go back and look at the sum and difference identities, I know a formula for the cosine of A plus B. Okay, so I'm going to flip back to page 1 and I'm going to look in my identities box. Okay, I'm looking for the cosine of something plus something. Okay, that's going to be this guy. Okay, so I'm going to go ahead and write this down. Okay, we know from this particular formula that the cosine of a plus b is equal to the cosine of a times the cosine of b minus the sine of a times the sine of b. Okay, we're going to apply this formula. Okay, so again, if you match up the left-hand sides, okay, I'm going to put an equal sign here. Okay, if you match up the two sides, we see that A is 120 degrees and B is going to be the 45 degrees. Okay, so we're going to plug these values in to our identity, and then we're going to simplify, and the number that gets spit out is going to be the cosine of 165 degrees. Okay, so let's try it. The cosine of 120 degrees plus 45 degrees is equal to the cosine of 120 degrees times the cosine of 45 degrees minus the sine of 120 degrees times the sine of 45 degrees. Okay, now we just need to plug in these values. Okay, so I'm going to go to the unit circle. Okay, do this if you need to. Okay, you may already have these values, memorized. Okay, I'm going to concentrate on 120 degrees. Okay, so here is my ordered pair that I need to look at. Okay, so what we can see here is that the cosine of 120 degrees is the x value here, that's going to be negative 1/2, and then the sine value is going to be the y value. Okay, so the sine of 120 is the positive square root of 3 over 2. Okay, we also need to look at 45 degrees, okay, which is right here. That's going to be this ordered pair. So you can see that the cosine of 45 degrees as well as the sine of 45 degrees, they are both the positive square root of 2 over 2. All right, so we just need to plug these values into our expression and simplify. Okay, so here we go. The cosine of 120 degrees is negative 1/2. So it's going to be negative 1/2 times the cosine of 45 degrees is the square root of 2 over 2. Then we're subtracting the sine of 120 degrees. Okay, that is going to be the positive square root of 3 over 2. We're multiplying that by the sine of 45 degrees, which is the square root of 2 over 2. Okay, and now we just, simplify these numbers. Okay, on the left side of the subtraction sign, we have two fractions that we're multiplying. So we multiply across the top and across the bottom. This is going to be negative square root of 2 over 4 minus, on the right side of the subtraction sign, we are again multiplying fractions, multiply across the top and across the bottom. Okay, in the numerator, you have the square root of 3 times the square root of 2. You can just multiply what's underneath the square roots. So we're going to get the square root of 6. Okay, 4 is going to be in the bottom. Okay, we end up with two fractions that we are subtracting. Okay, we need a common denominator. Both fractions are already over 4. Okay, and then we just need to subtract across the top. Okay, so this is going to be negative square root of 2 minus the square root of 6. You can leave the answer like this. Okay, if you want to, you can factor out a negative 1/4. Okay, that will leave you with the square root of 2 plus the square root of 6. Okay, so either answer is acceptable. Okay, the great thing about doing this, okay, you do need to be able to do this without a calculator, but if you're like doing homework or something, you can check yourself. Okay, I can plug in these values that I got and make sure that it matches the decimal expansion for the cosine of 165 degrees. Okay, so for example, I'm going to go to my calculator. Make sure your calculator is in degree mode. Okay, you can see right here mine is. If you need to change it, if yours is in radian mode, you need to go to mode and you need to toggle between the radian and degree mode. Okay, so here I'm going to go ahead and punch in cosine of 165. Okay, that's the decimal expansion. Okay, and then I'm going to plug in what I got to see if it matches. Okay, I found my answer to be this quantity, the negative square root of 2 minus the square root of 6 over 4. Okay, so I'm going to pop that in. Okay, so I'm going to put the entire numerator in parentheses, negative square root of 2 minus the square root of 6. Close the parentheses on the numerator, divide this by 4, And yippee skippy, I've got the same decimal expansion. Okay, so that is how this works. Okay, we can use these identities, okay, to come up with the values, the exact values of the 6 trigonometric functions for angles that are not on the unit circle. That's what's great about these identities. Okay, let's try another one. Okay, so in part B, we're going to tackle the cosine of 7 pi over 12. Okay, and we know that 7 pi over 12 is not on the unit circle. So we can use a sum or difference identity if we are able to come up with 2 angles on the unit circle that we add or subtract to get 7 pi over 12. Okay, so this is going to be a little more difficult because it's a radian measure. Okay, but the hint here is that the denominator is 12. So you're probably going to be working with something over 3 and something over 4. Okay, so we're going to be looking at the pi over 3 segments and the pi over 4s. Okay, there's some combination of those that's going to give us the denominator of 12. Okay, so let's fidget around and see what we can come up with. All right, so in my mind, this is the best way to do it. Okay, I have a denominator of 12. Okay, so let me write this down. I'm just going to stick with adding, but we could do subtracting. Okay, so something over 12 plus something over 12. Okay, because if we're adding 2 things, we need a common denominator of 12. Okay, so that when we add across the top, we'll keep the same denominator. Okay, so in the numerator, I've got 7 pi. Okay, well, what's going to add up to 7 pi? Well, 3 pi plus 4 pi. Okay, so in my mind, that's how I can compute the 7 pi over 12. Okay, so if you look at this, these guys reduce. 3 pi over 12 is the same thing as pi over 4. And then we're adding 4 pi over 12. That's pi over 3. Okay, so that's what we're going to use here. Okay, the cosine of 7 pi over 12 is going to be the same thing as the cosine of pi over 4 plus pi over 3. Okay, if you add pi over 4 plus pi over 3, you're going to get 7 pi over 12. Okay, again, you cannot distribute. That's bad, bad, bad. Okay, you have the cosine of something plus something. You're going to have to apply the sum formula for cosine. Okay, that's the same thing we used in part A, so let's just get more practice with it. All right, I'm going to line this up. Cosine of A plus B. This is going to be the cosine of A times the cosine of B minus the sine of A times the sine of B. Okay, you can flip back to page 1. It's formula number 1 that I'm applying here. Okay. All right, so when I'm doing this, okay, if I line up these 2 statements on the left of the equal sign here, okay, pi over 4 is going to be my A value, and B is going to be the pi over 3. Okay, so I just need to plug these guys in. Okay, so we're going to get the cosine of pi over 4 plus pi over 3 is going to be equal to the cosine of pi over 4 times the cosine of pi over 3 minus the sine of pi over 4 times the sine of pi over 3. Okay, now we need to go get these individual function values off the unit circle, plug them in, simplify, and we're going to be good to go. Okay, let's go to the unit circle. We need to concentrate on pi over 3 and pi over 4. Okay, we've already had experience with pi over 4. We know that 45 degrees is the same thing as pi over 4. Okay, they are the same. So I'm just going to go ahead and change this out. Okay, we know that the cosine of pi over 4 is the square root of 2 over 2. The sine of pi over 4 is the same thing, square root of 2 over 2. I'm also interested in pi over 3 here. Okay, so here's its ordered pair. Okay, so if we look at this, the cosine of pi over 3 is going to be 1/2, the x-coordinate, and the sine of pi over 3 is going to be square root of 3 over 2. Okay, so we just need to plug and chug these values. Okay, so here we go. Okay, so we're going to start with the cosine of pi over 4. That's the square root of 2 over 2. We're going to multiply that by the cosine of pi over 3. The cosine of pi over 3 is 1/2. Then we're subtracting the sine of pi over 4, which is the square root of 2 over 2, times the sine of pi over 3. The sine of pi over 3 is the square root of 3 over 2. Okay, so we plugged everything in. We just need to simplify this expression. Okay, we are left with, a set of fractions that we're multiplying, and then we're subtracting another pair of fractions that we're multiplying. Okay, so this left pair, I'm going to multiply across the top and across the bottom. I'm going to get the square root of 2 over 4. I'm subtracting. Again, I want to multiply across the top and across the bottom. We're going to get the square root of 6 over 4. Okay, so we can leave the answer like this, or we can factor out the 1/4 and be left with the square root of 2 minus the square root of 6. Okay, either way you want to write the answer, that's fine. They're equivalent. Okay, last thing you should do, if you can, you should check yourself. Okay, so I am going to go to my calculator and plug this in. Okay, I do need to switch to radian mode. Okay, so I'm going to go to mode. I'm going to go to radian. Okay, and you can see up here I'm in radian mode now. Okay, and I'm going to compute the cosine of 7 pi over 12. Get the decimal expansion. I need to compare it to what I got as the answer. Okay, I got the square root of 2 over 4 minus the square root of 6 over 4. Okay, if I get the same decimal expansion, I know I did this correctly. Okay, so let's punch it in. Square root of 2 over 4 minus square root of 6 over 4. I am good to go.